we have a short 15-minute presentation about the role of software-defined vehicle and AI in ADAS development as a Tier 1 supplier. Is that a correct summary of your presentation so far? Why don't you come up and see if you can make that happen? And interestingly enough, this is not a presentation by Miroslav, you're here. Great, because we have community updates after this. Not by a software center company, but by a company that is sniffing around software center, if I may say so. Is that a fair way of putting it?
Yeah. All right. Yeah. I mean, that's correct.
Go ahead.
Okay.
It's not on the slide, so you may want to mention it.
I will do that. So let's see if I can. Okay, so here is my name. So my name is Tobias Aderum. I'm the Director of Research and Innovation at Magna Electronics. And the title John already presented. We've been in, let's say, a journey of acquisitions and mergers. So I started at Autoliv. I never quitted my job, and then it was bought by Qualcomm. It was put in pieces, and then Magna bought the active safety part, which I am part of. So located here in Sweden, in Vårgårda, we have our research center. And my talk will be a little bit about, you see, the impact of software-defined vehicles and AI, but also why don't we have self-driving vehicles on the street? Elon Musk has promised it every year since 2015. You maybe seen some videos on YouTube. He said, next year we will have full self-driving. 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 And yeah, now we're 2024, right? And there was an event recently, and there are some rumors, and it was released, but there are some rumors that there was a remote driver actually driving the car. So who knows? It's partly a show, right? Where I work, we have, it's called electronics within Magna. Magna is big, making everything from seats to complete vehicles. In the electronics part, we have some competence areas. It's both linked to hardware solutions, but it's also linked to ADAS, advanced driver assistance systems, and autonomous driving. And we've been delivering automotive safety for quite some time. We produced a lot of components like 142 million cameras, 75 million radar sensors, and 33 million ADAS ECUs. So that's the hardware part of it. And then what do we do? What does our system achieve? So one big part of that is safety, to give you vehicles that can get 5 stars in NCAP ratings, providing these kind of functions like blind spot detection, lane departure warning, automated parking, emergency steering, and front and rear emergency steering. And the point with these systems is to prevent accidents from happening in real life. So it's important because it's 1.2 million fatalities around the world. So we got a lot of help from legislations and consumer ratings like Euro NCAP, because they are driving technology adoption to the market. When we have these technologies, this vision system, radar system, it's easy to add comfort and automation to it, because the hardware is there, the major cost is taken, as software is not supposed to cost anything according how our product is purchased and acquired by OEMs, then yeah, they expect these kind of things for free. So with that, we can have this adaptive cruise control and traffic jam assist and lane centering and so on. And then we also have some parking help and that could augment the driver. So these are the products we are offering, and what's coming right now is systems that are perceived as self-driving. It's called navigation on autopilot. So it's working perfectly. Tesla is a pioneer with this, but also some Chinese companies are deploying this to the market. So it's self-driving. Very fine. Good. Everybody's happy. Well, they expect the driver to be fallback, and as the driver don't expect to be the fallback because it's self-driving, right? This is a misconception, and then if accidents happen, then there might be some cases where these persons that's supposed to be fallback and intervene if the car does something stupid have to go to court, and we will see where this end up, but it's not really the products are maybe not always expecting the consumers' expectations. There's a mismatch there. So what we are trying to do as the Tier 1, we are trying to get some more novel methods of working with software in our company, because traditionally we are sourced by components and some OEMs like to do that. So that's hardware with some software flashed on top of it. But the trend is going to be more integrated systems. So that's why we are also serving customers to integrating third-party software, but also taking the full system responsibility. So that's how we try to operate. So the market today, as I mentioned, there is a lot of legislation that is driving our products, but it's also changing a little bit because we get the new technology like AI that enables us to develop things faster, and the expectation goes faster, and the expectation is not to develop a product and then it will function for 15 years and there's no problem. The expectation is that it will be updated. And since the automation is increasing, also the complexity of functions goes up. So we try to show that with this picture. So going from smart sensors, where you have the camera, you have all the algorithms taking place in the ECU integrated with the cameras. That's what we call smart sensor. Going to this centralized architecture where you have one bigger ECU in the vehicle, and then the sensors are more like heads, and then data is streamed to the centralized solution. And what we also will see more coming in the future is that we will have vehicle to everything communication. So we're not there yet, but the vehicles will talk to each other. They will share their sensor information with each other, and this will give a better view of the surroundings and better interaction with road users and so on. This requires a little bit of standardizations and maybe more market pull. So opportunities with this is to have what we call the collective perception, where the vehicles share their sensor information. So all vehicles maybe don't need to have all the different sensors, and we can do traffic intelligence in cloud services and distribute to the vehicles. And then you can reach not just premium market segments, but also entry market segments who can't afford all the products. And this is kind of pooling of resources, because those vehicles that are more capable, that has these high-end systems, they can share some of their resources with others, and they can maybe pay for usage. And of course, cross-domain integration. So I work a lot with safety, but you have powertrains, you have infotainments, and so on, and these can be more integrated. And then with AI and ML support, we can also deploy more innovation at a faster pace. So what's the problem with software-defined vehicles, and why is it going slow? Well, big OEMs and Tier 1s, automotive companies, they have their legacy, the processes. We have to do verify all the products. It has to be functional safe. It has to go through a lot of validation and so on, because we are talking about safety. So it's not okay if the system fails sometimes, reboots sometimes, and then that was a critical situation and somebody gets killed. So the transformation with the software-defined vehicles is about decoupling the hardware from the software. And why it looks like this is because automotive is extremely cost pressurized. So the chips, they are they're really optimized for the functions. So I'm not talking about the premium market segment where you have, like Tesla can have extra compute resources. I'm talking about the entry markets and maybe mid markets where everything is optimized. The purchasing negotiate about euro cents. So you can only afford as much memory and compute resources as the function needs. So everything is optimized in detail, adapted to the hardware. But with software-defined vehicles, we want to be able to build platform. Cost of these new chips is going down. And the customer expectations is rising. So this is something we're looking in, but the automotive is not yet there. and I will speed up. This is an example how we use AI to reduce a little bit the cost of training our AI models. I mean, we have CNN models deployed, embedded on the vehicle. So we've been working with AI for 4 years. But now when the functions complexity increases, we need to have more coverage. We can use synthetic data to augment data. We can also generate, interpolate. So if we know we have data collection in certain scenarios, and then we can interpolate if we can factorize it. So this kind of development engineering becomes increasingly important, because otherwise it's so much data that needs to be collected, and then you need to validate across platforms and so on. So reused synthetic data are key items for us. And we're going towards the feature development perspective rather than the hardware focus and what you can do with the hardware. And in this, we need also to change the model of how we are collaborating in the automotive. We can't have it the traditional way where purchase decides the lowest Eurocent. This needs to be a better integrated and collaboration models. And with this new navigation on autopilot, where it's basically self-driving, and we need to take responsibility for the products for 15 years. 15 years ago, there was no e-scooters on the roads. So we need to have data feedback. We need to update our ML models based on new things that come into the traffic scene. And how can we do this? Everybody wants to sit on the data because data is the new gold, but nobody wants to share and find business models and the feedback loops. They are not there yet. So this is something that I think it will be interesting for us to investigate, whether we can get help from that from the software center and the consortium. So with that, I think I basically covered this. With that, I would like to say thank you.
Thank you for wrapping this up. Really appreciate it. We have time for one question. Any questions? Okay, so Anders, Cecilia, Anders was 2 milliseconds faster than Miroslav. So.
Well, thank you for the great presentation. I was interested in your thoughts about Tesla's new version 12 of their FSD, which basically are taking an end-to-end approach with neural networks, both for the perception, planning, and control.
Yeah.
Do you think that's the future?
I think it's extremely interesting development. I think when it comes to like legislations and so on, authorities make recalls based on vehicle behavior in traffic. And when you have end-to-end training, you don't, and the AI models are not always linear, and you know what to fix and what to tune. So this is a challenge. Maybe with more explainability, maybe with good AI modeling, we can fix this. But it's not, if there's a behavior in traffic we need to fix, this end-to-end learning is maybe not the best approach always. So we need to find a good way forward here. I don't have the perfect answer, but I see that it's being worked on with Tesla and in China. But to be honest, I'm not 100% convinced yet. Yeah.
Good. And then Miroslav, you got your chance to ask your quick question anyway. We'll take it from your theme presentation part.
Okay, thanks. I was afraid you would say this. So I'm a bit curious about, you're referring to Tesla quite a lot, but there are other companies like Mercedes-Benz that released the self-driving features last year. So why Tesla? Why not other real OEMs?
Yeah, that's a very interesting question, and those have actually released functions that are level 3, where the automation system is the fallback, but in their instruction booklet they have written that in case of exceptional situations you anyway need to be the fallback. There is some debate around that. I think when you go, I mean, there's a reason why these self-driving companies are in Southern California, Texas, because you always have good weather. The challenge is really to have something that is knowing when it's exiting the operational design domain, and to be able to measure that, to have runtime performance, because you can't just trust the cameras. You need the radars, you maybe need potentially LiDARs or other sensing modalities. You need to compare the runtime performance so you know when you're exiting the ODD. And there are requirements that is really limiting to go in high speeds with the automation system as fallback. This is small passable object. So depending on how fast you want your system to drive, you need to detect a box that is maybe 15 centimeter high at more than 150 meter in different conditions. And if you can only detect it in 60 meters, you need to adapt the speed to that. And this is a huge challenge. And Mercedes is on a good track on that, I would say. We are working with them. We have some projects linked to adverse weather sensing and those kind of things. But coverage is a challenge. How do you know that you covered all the situations and requirements? And how do you know when you exit what's defined within your ODD? I hope that's answer to your question.
Good enough. Thank you.
Thank you.
Tobias will be here during the rest of the day as well. Let's give Tobias an applause and thank him. Thank you very much, Tobias.
Thank you.
We'll take, well, I mean,
You want that one?